You're in a car going somewhere when suddenly this happens. This is a car crash. It's nothing unusual, and most likely you've seen one. A car crash is more to the story than you know. From mechanical failure, navigation error, human mistakes, weather conditions, unicorns, or even other factors, a car crash has a lot influencing it. Today, with the magic of data science, we are going to be producing beautiful visualizations for you to understand better what causes a car crash. We're from Group 8, and today we'll be exploring car accidents. Our members are Shim, Tyler, Pam, Make, Smart, Win, and I, Wasu. And we've all contributed our parts to this slide's data, but we've decided that for the narration, only one of us is going to be doing it so that you, the audience, can get along better with what we're saying. US accidents, a countrywide traffic accident, is the dataset that we're going to be using, and it has 3 million records from 2016 to 2019 from over 49 states of the US. First, to gain an understanding of the dataset, we're going to be looking at the number of accidents in each of the states. And as you can see here, the most intense blue color, which is California, has the most number of accidents. When we cluster this data, we can see that there are 4 main groups of number of accidents occurring. So we have California in its own league, then followed by green states, followed by orange states, and finally we have the blue states. Now this is interesting because the blue states aren't close to any water source, and they thus have the lowest number of accidents. But why? From the clustered data, a question arises. Is the frequency of accidents relative to some factor? Since the states with the most frequency of accidents were those near water, a possible relationship could be hypothesized to the humidity. From the map, humidity appears to correlate to the number of accidents. This relationship alone is not enough to determine whether it is a real factor. One may hypothesize further that humidity causes wet and unsafe roads. This must be proved. Trying a different factor closely related to humidity, namely precipitation, yields an answer in the same direction. It appears these two factors are affecting the number of accidents caused. But what was the root cause of these issues? One possibility could be that more humidity and precipitation would decrease visibility, resulting in higher accidents. Putting this data onto a graph, we can see that the answer is no. Visibility does not correlate to the number of accidents, because if you see carefully, all of the states have about the same amount of visibility. So we can see an important concept from all of this, which is correlation does not imply causation. And even when talking about humidity and precipitation themselves, we can't say that they caused the accidents to occur directly because we don't really have enough data to prove that. But what we can say is that they correlate somehow. They go up when the other thing goes up. So that's the only thing that we can say. Now for other relationships, we have driver age versus accidents. So as you can see here, the people in the lower age groups, which are 16 to 17, they have the most number of car crashes. And this is also reinforced when we look at a map of the population by age. And we can see that the states like California, which has the most number of car crashes, they have the most of the population in the age group of 0 to 18, which are youngsters as well. Now, we're looking at a different factor, severity. First, before talking about the data itself, let's understand what severity is. Severity is a measure of how much of an impact an accident has on the traffic around it after it occurred. And it ranges from a count of 1 to 4, with 1 being the least severe to 4 being the most severe. So we can see here that the states of Wyoming and South Dakota, they stand out with the highest severity in car crashes. Now we're going to be looking at severity versus other factors. So first we have wind speed. Wind speed is how fast the wind blows in miles per hour, and it's going to be represented by the numbers in white in this case. And as you can see here, the higher the numbers, the higher the intensity of the color. So what does that mean? That means that wind speed and severity correlate to one another. This is an interesting thing that we have found. Next, we have visibility versus severity. Visibility is how much of the roads you can see in miles, how far you can see in miles. Now, the lower the visibility, the higher the severity, as you can see in this graph. And this is also interesting because it's another correlationship. So finally, in the end, what can we say? Well, we can only say that multiple factors affect car crashes as explored in this presentation. And we really can't directly say that they cause car crashes directly. So if we want more answers, or even if we want to learn more factors, we are going to be needing more data. And from that data, we are going to have to apply data science to extract useful insights. And this is where I would advise you all to take a look at data science, because a bunch of numbers that you may not have known had some interesting story could suddenly tell you something that you never knew. Thank you for listening to our presentation, and we hope you have enjoyed it and have a great day.